work our way down. And again, I've got a smiley face on it because I was meaning to make this post for a while back in 2014. I had been working on it for almost 2 years. Starting in 2012 to 2014, I was noticing and documenting the pattern of earthquakes around the plates. And by 2014, I was sick of being denied, and I decided I was going to put it out in a post explaining how to watch and what to watch for. So, at the start, let me just read it to you. Major stress has built upon the edge of the craton over the past 7 days. Multiple 4.0 M plus events in Oklahoma, Nevada, and off the west coast. The pressure placed upon the unsubducted edge of the plate has now resulted in a 2.9 3.0 earthquake in North Carolina along the Blue Ridge Mountains. And I can click on this graphic, or you guys can click on it. We will. Now this is me in 2014, guys. So you can see there's 4.0 earthquakes that struck off the west coast. Hopefully you guys can see all this. Yeah, you sure can. 4.4 off the west coast off Vancouver, followed by a 4.2 down in Nevada at Bittner Butte, the spot that I just showed you, right? 2 years ago, Bittner Butte struck. Then a series of 4s in the Midwest, then lighter movement over to the East Coast. All right? And then I have a diagram of the craton, which I put out so many times. But you can see the inner portion, the continental crust that has remained relatively stable for the past 600 million years. And that's their time frame, guys. Don't argue with me on time frames. I don't want to even get into that. But you'll be able to see 7 days of earthquake shows that the craton was pressed from west to east, and whatever was left over after the fracking operations moved. And the reason there's 3 4.0s at the fracking operation instead of 1 is because of the superfracture principle. Superfracturing is a term I had to create to describe what happens when one 4.0 or greater earthquake strikes, and it causes other 4.0 or greater earthquakes by the cracking of the casements of other wells. And other wells get damaged. They release more gas under pressure and fluid under pressure into shallower portions of the rock, unintended, after one force strikes, and then you see other force strike. That relieves most of the pressure, but whatever's left over off that transfers to the east along the edge of the craton, and you see the earthquake, the 2.9 on there. This is back in 2014 when I started to notice this, okay? Well, actually 2012, 2013. By 2014, I'm documenting it and putting a post out explaining it. So, anyways, the pressure placed upon the unsubducted edge of the plate has now resulted in a 2.9 along the Blue Ridge Mountains. This was expected. Expected? How? Why? Who was expecting it? To begin, I can answer the who portion right off the bat. The who would be myself, as well as my viewers and readers, who have been studying these events real time for the past several years. Now let's get into the why and how. First things first, you might be asking why the professionals are not forecasting earthquakes 3 to 7 days out. They, professionals, still deny that earthquakes transfer from one location to another. However, as most of my viewers and readers know, we have been able to forecast several earthquakes using this new knowledge of pressure transfer across vast distances. And we can click on this, and it'll take us to a search for Dutchsinse pressure transfer. Okay, you can search all my posts on pressure transfer. And then I've got another search for pressure transfer there. So you guys, you can welcome to click that and read all on pressure transfer and what I've discovered. Professionals still in denial over something I'm using to forecast where to expect earthquakes to happen in a week's time or less. 3 to 7 days warning time can be achieved. I knew to watch North Carolina, Tennessee, and Virginia based upon the movement happening in Oklahoma, Nevada, and off the West Coast. Let's get back to the graphic. We knew to watch the East Coast because of the movement in the Midwest and on the West Coast. Makes logical sense, right? This isn't guesswork. You can know for certain that when pressure is placed on a relatively solid object on one side, the object being pressed will move in the opposite direction from which the pressure is coming. And then I have a picture here showing what happens when you press on the side of one thing, the opposite side moves in the opposite direction. Now, nobody's shocked. Let me just stop right there. If you take you guys likely have a kitchen or dining room table, all right? If you go on one side of the table and put your hands on the side of the table and push, the table will move, right? usually, if it's not too heavy, the table will move. And when you push on that table, you're not shocked to see that the other side of the table moves away from you, are you? I mean, you wouldn't expect it to come towards you, would you? When you're pushing on the table, all of a sudden the other side folds up and starts coming back at you. You've got a problem with space and time, okay? So, when you push on something on one side, it moves on the other. And if you bend something on one side upwards, it cracks or flexes on the top portion that's bending outwards. By pushing inwards, it's pushed outwards on the other side. Does that make sense? Basic Newtonian physics. Okay, that being said, like plates of ice, cracked, floating on a lake, if you push on one plate, it will push the plate next to it. Now imagine those plates are closely butted up against one another with not much area to move laterally. And then I have a graphic, a GIF of fracturing ice over a large area off the coast of Alaska. And you can see the ice sheets breaking with waves underneath. Now you can imagine that seismic waves, just like ocean waves, can crack and distort plates like sheets of ice. And then you get movement along the plate edges or boundaries like sheets of ice floating on top of water, only instead of floating, we are suspended like a shell on top of a viscous liquid. We are suspended over this floating over this magma that's down below. So, anyways, like plates of ice cracked, if you push one plate, then the plate next to it, imagine those plates closely butted up against one another with not much area to move. The pressure will build upon the entire structure of the plate while trying to evenly distribute itself throughout the mass. So in other words, when the pressure hits the plate, it will evenly spread out across the plate and try to put itself out across the whole plate to even itself out. I'm trying to speak in simple terms here so everybody can understand. Even a child can understand this. All right? So when the pressure is placed upon the bottom side of the plate then distributes that pressure outwards evenly. But unfortunately, we'll find out that the plates have weak spots where the pressure releases when it's trying to put that pressure out evenly around the whole plate. So the pressure will build upon the entire structure of the plate while trying to evenly distribute itself throughout the mass. The stress will find the weakest points and release at those points. The edge of the craton is the defining line between the solid plate and the weaker deformed edge. Now let's get back up to the craton diagram. Okay, here's the craton diagram. Again, let's take a look at it. All right, so our weak spot is going to be where the solid plate in brownish orange meets the deformed edge of the craton, the purple portion, and where the purple portion meets the blue coastal plain, where it spreads out and even becomes even more weak or weaker. So we see earthquakes develop upon these lines, the interior and exterior, deformed and stable edge of the craton, starting on the west coast, pushing to the east-southeast. Now look where the brownish, reddish, rusty color spreads out right across Yellowstone. Do you see that? Goes right over Yellowstone, goes down across our fracking operations of Wyoming, goes down across the Front Range of Colorado, again, our fracking operations on both sides, gets down into New Mexico, fracking operations on both sides, goes down through Texas, Fort Stockton, fracking operations on both sides, up through Texas, all the way, oil fracking, pumping operations, going up into Oklahoma where it makes the bend, fracking operations on both sides, goes over into Arkansas, fracking operations on both sides, goes down into Alabama, Tuscaloosa, fracking operations on both sides, and then goes up the East Coast where we have fracking operations going across Virginia where they hid the earthquake last week, right? You guys remember? When they hid the earthquake and changed it from 4.3 to 3.4, blamed it on a mine collapse at the fracking operation there. Get up into Pennsylvania and New York, you have a few fracking operations. Now, I keep saying fracking because they keep getting hit. All right? And they keep getting hit all the way along the edge of the craton because they've put those there to get the gas out along the deformed edge of the craton where it meets the stable edge. There's huge amounts of gas. All right? So, now you understand a little bit more upon the edge of the craton and the fracking operations, how that plays in. Well, when there's pressure placed upon the edge of the plate overall from the west coast, it seeks out those operations along the deformed edge. And it releases there. Okay? So, now, moving on. Instead of cracks and mounds of ice along an ice sheet fracture zone, the rock formations of the fractured plate have formed mountain ranges along the weak inner edge of the craton for eons. Thus, the mountains in the United States are now confirmed to literally be plate material forced upwards via pressure which comes from the west. When subduction is not capable of keeping up with the tectonic pressure from the Pacific plate, the pressure does indeed transfer across vast distances in a short amount of time, days or less, even hours in some cases. And we can click on that. It takes you to a search on all my pressure transfer, and in a short amount of time, the days on that. You guys are welcome to click on that. Now I give an example. In 2014, this is me in 2014, I give a 2012 example. January 2012, the craton edge is revealed by earthquakes. Excessive activity along the west coast caused by excessive activity in the far west Pacific. The plates of the planet seen in the diagram are all being displaced by the Pacific unrest event, global surge. Now we'll click on this graphic. 2012 graphic showing again, look at all our activity on the west coast. Look at that, guys. If you saw that right now, you'd freak out, right? So here it is. This is 1 week's worth of earthquakes, and it shows that they developed on the west coast heavy, then spread out to the Midwest right along the edge of the craton, and then went up the east coast on either side of the deformed edge. Okay? It's obvious. And then I have my plate boundary diagram here showing you how the plates butt up against one another, and where the pressure builds here off the northwest, it pushes our whole plate, and you would expect it to keep going all the way over to the mid-Atlantic, but it curves along the edge of the inner portion of the craton, I believe just because of the way the plate's shaped. So anyways, we'll get back over, carry on. So this is my 2012 diagram showing the progression of earthquakes across the plate. This all plays into forecasting. You have to understand that earthquakes progress across distances, even though professionals say they don't. They got it wrong. They do progress across distances. Smaller earthquakes in one location on the plate cause smaller earthquakes in another location on the plate. A 4 on the west coast can cause a 4 in the Midwest. A 4 in the Midwest can cause a 2 to 3 up the East Coast. And it can all happen in a few days' time. So, get down here. Next paragraph. When the pressure transfers across the solid mass of the solid portions of the plate, it finds weak points to release, such as fracking operation injection wells, oil drilling locations, hot springs, dormant volcanoes, and even some deep mining locations. And you can click on each one of these. It'll take you to examples where I've documented in the past of earthquakes striking at each type of location at times of heightened unrest upon the edge of the craton. The fracking operations, oil drilling ops, dormant volcanoes, and deep mines act like perforation points where the pressure is releasing. No doubt at this point I can say for certain the rolling foothills of the New Madrid seismic zone can also now be confirmed to be caused by past built pressure, causing a buckling in the plate and massive earthquakes in the Midwestern United States. And the reason I say that is because the pressure always transferred from the west coast to the east coast. Always transferred literally from California up to the Pacific Northwest, pushing to the east and causing earthquakes in the Midwest naturally at the New Madrid seismic zone. Now we've robbed that pressure with the fracking operations over to the west. The new drilling fracking operations are acting like a relief valve along the center portion of the craton. Normally, naturally, the pressure coming from the west in the past would have been placed on the center of the craton in Missouri and the New Madrid seismic zone. Now, the fracking operations, drilling operations, are, quote, weak points, extending a few miles down into the crust, like perforations in a cardboard box, weak points where bending and breaking can occur. Notice the thousands of 3.0 to 5.0 earthquakes which have occurred during the past few years in Oklahoma, Arkansas, Texas, Kansas, and Colorado, all occurring unexpectedly and all occurring at fracking operations. Notice the hundreds of 3 to 4.0 earthquakes at the dormant volcanoes along the deformed edge of the craton in Nevada, Arizona, Idaho, Wyoming, California, and even at dormant volcano, extinct volcano in Georgia. Click on it. Feel free to search through that, see the Georgia volcano, all that stuff, guys. You may know about it. If you don't, I don't have time to get into it now. Pigeon Mountain, I found a volcano in Georgia, unmarked by the USGS, being mined by a company called the Vulcan Mining Company. Anyways, notice the movement of Yellowstone region, moving 1/2 inch southeast, pushed southeast along the edge of the craton. Notice the confirmed uplift of the magma chambers of Yellowstone Volcano, Mount St. Helens, Mount Shasta, and Mount Rainier. The uplift of the magma chambers, the movement of the craton edge, and the multiple earthquake swarms associated with each location proves that the pressure is coming from the west. Unlike modern day geology thought, which says one earthquake does not lead to another, and that the spread of the mid-Atlantic ridge is what causes mountains to form in the Americas. I should have put a smiley face on that. The subduction process is not keeping up with the movement associated with the Pacific Plate unrest event, which has been occurring since before the 2011 Japan mega quake. The dozens of unexpected large volcanic eruptions globally in diverse areas, and also the rumbling of ancient volcanoes in Scotland, Russia, Moscow, Mono Lake, California, proves the unrest event is indeed global. This unrest event, as I'm calling it, was referred to as a global surge by professionals a few months ago in Vancouver, Canada at the annual geophysics meeting. And they called the same thing that I'm talking about in this article is the same thing the professionals came out and confirmed. They just called it global surge. I called it global unrest event. But professionals are acknowledging a surge in global large earthquake events, but say they are puzzled as to why it is occurring. They obviously don't know that this global surge or unrest event is being caused directly by a deep disturbance in the asthenosphere, which centers around Vanuatu and the Indo-Australian plate boundary north to Japan and east across the entire Pacific plate to Central and South America. And I have a graphic here showing the progression of earthquakes. It says above, past 7 days of earthquakes up to December 15, 2014, shows the deep asthenosphere cluster point at Vanuatu and the 6.2 which struck northwest of Vanuatu in the Philippines, and I think it's Vanuatu. So you can see the deep earthquakes causing shallower, larger earthquakes, and it spreads to the west-northwest, and it happens every single week. Repeatedly, we see deep earthquakes in the 4 to 5.0 range, occurring at approximately 3 to 400 miles depth. The area inside the Earth, known as the asthenosphere, that's 3 to 400 miles down, we have the semi-melted area called the asthenosphere. These repeat 4 to 5.0 earthquakes will happen back and forth between the West Pacific and South America and Central America. Both locations, West and East Pacific, having multiple large volcanic eruptions, some at normally quiet volcanoes. The unrest in the asthenosphere, 350 miles deep, always is shortly followed by shallower, larger earthquakes within approximately 1 week or less. And here's my graphic. I put this out back in 2014. Deep earthquake with a zone telling people where to watch for a shallower, larger earthquake. Okay? And this was struck, by the way, this is an example, because this was struck 2 days later by a 6.5. And here's an asthenosphere graphic showing you how the asthenosphere is the semi-melted area below the plate coming up from the mantle. And the core is not solid. That's an incorrect graphic that I just had to use. If you see a cluster of deep earthquakes, watch the nearby adjacent area for a large, shallow earthquake. As compensation movement, pressure transfer. The larger, shallow earthquakes usually occur to the northwest of the asthenosphere deep earthquake swarm locations. For instance, usually, after we see a swarm of deep events in Papua New Guinea, we see a larger, shallow earthquake strike northwest in the Philippines or in Japan. Another example, usually after we see a swarm of deep events along the Chile-Argentina border, we see larger shallow earthquakes strike northwestern Peru to Central America. The unrest event happens back and forth like a tennis match. As the pressure comes up from deep within the earth, from a yet unknown source, and I've since figured that out, by the way, guys, the transfer of the force must be causing a displacement of the Pacific plate from beneath. The area beneath the plates, above the liquid molten core of the earth, the semi-melt area known as the asthenosphere, is the interacting point between the fluid and the solid. This area is having earthquakes due to some internal force causing a displacement on the semi-melt. The semi-melt then must be displacing the upper, more rigid plate, which subsequently causes displacement across vast distances on the plate boundaries around the entire planet. Finally, this leads us back to the United States craton pressure coming from the northwest, pushing to the southeast. Now you can understand why we're seeing earthquakes at fracking operations, dormant volcanoes, ancient volcanoes, extinct volcanoes, why multiple new eruptions are happening, why areas are being uplifted in a short amount of time, and why the professionals are going to have to rewrite most of their textbooks and give me a shout out finally in a footnote for discovering all of this on my own in my spare time while also working on weather, solar, and other false flag information. Smiley face. Cheers, and feel free to run this story by any professional you wish. Now, that's in quotes because professionals we know are not too professional. After years of watching this happen, I think it's high time that I explained the process in text and how you can repeat it. Again, watch for deep asthenosphere earthquakes, then watch the areas nearby, adjacent of those deep swarms, for shallow, large movement. In the USA, watch for pressure from the west, showing as multiple 3.0 to 5.0 earthquakes off the west coast. Then, watch the craton edge as the pressure transfers across Washington, Oregon, Idaho, Montana, Nevada, Arizona, Utah, Colorado, Wyoming, Kansas, Texas, Oklahoma, and watch these events terminate at the Arkansas border. You will quickly see that the pressure which terminates at the Arkansas border finally releases itself via 1 to 2 events on the East Coast, US, along the edge of the plate. And then I give one final real-life example of the 5.9 that struck on the East Coast in 2011. One final real-life example. In 2011, the 5.9 earthquake which hit Virginia, causing damage on the East Coast of the United States. You guys remember the earthquake that caused damage to the Washington Monument back in 2011. Big one, 6.0 almost. That earthquake was preceded by a 5.0 earthquake at the Colorado fracking operation and multiple 4.0 earthquakes along the edge of the craton in Wyoming, Colorado, Oklahoma, and Arkansas. So before the East Coast was hit, you can see on the map, see all these earthquakes? Okay? Before the East Coast was hit, a huge swarm hit Colorado, 5.4 and multiple 4s. And that added up to one single 5.9 to the east within a few hours' time. It was like 12 hours before the swarm in Colorado started. And then, boom, the East Coast was hit. Pressure transfer is real. It happens virtually real time and is the first step towards accurately scientifically forecasting an earthquake multiple days before it occurs, getting it down to a specific region to watch over a specific short time, 3 to 7 days or less from the point of the pressure showing itself via a swarm. Currently, today, December 15, 2014, when I wrote this, there are 2 main swarm locations. And I'm talking about then I go into where to watch for the next week and I put my forecast in, and that's it. So this is, again, I say, we need to watch the West Coast, la, 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 and then it all got hit, and I put all the stuff in there. So that is the post. Now, I've got a book I'm writing, which is much more detailed, and including my new discoveries on the core of the Earth and the asthenosphere and the peeling off of the asthenosphere and all the confirmations, because everything I read to you here in 2014, like I said, has now been confirmed from studies. The pressure transfer, the asthenosphere earthquakes causing shallower, larger earthquakes, confirmed by Italian scientists, up to 1,000 kilometers away, too. They found out that a deep earthquake can cause a shallower, larger earthquake up to 1,000 km away, guys. Crazy, isn't it? So, there's my post. That's the explanation. Let me sum it up real quick one more time. If you live in the West Coast, you'll have warning signs before an earthquake strikes. A larger earthquake, especially. So, when we're talking about 5.0 activity and greater, we'll have a day or two's warning for sure. The volcanoes will start swarming. Your pumping operations will start getting hit. You'll see lateral movement happening along the fault zones, and then boom, you'll get hit right along the coast or right off the coast, usually right off the coast. And when I say right off the coast, it's usually to the northwest. So northwest California, northwest United States. Then after that movement happens, then we see lateral pressure transfer down the coast, and we see larger earthquakes strike in Southern California, similar to what struck up north. So you may have seen that new San Andreas movie where the earthquake strikes down in near Hoover Dam, down in southern Nevada, and then it strikes up the coast in, I think, San Francisco, I'm pretty sure, okay? Well, it would happen the exact opposite. So first San Francisco would get hit, then you would see movement down the coast, most likely. The only time we see large Southern California movement is when we have large Central American movement, large South American movement, so that can switch things up, of course. But when we're talking about the regular pressure transfer, we see it build to the northwest, push down the coast, and then to the east. So along the edge of the craton is the way we forecast earthquakes. You watch along the edge of the craton for that movement, and the movement off the west coast determines the movement in the Midwest and on the east coast. And the movement on the west coast is determined by movement in the West Pacific, with our deep earthquakes in the asthenosphere causing shallower, larger earthquakes. The deep earthquakes cause shallow, large earthquakes nearby the deep earthquakes. Those shallow, large earthquakes cause displacement upon the edge of the whole plate, and we'll see pressure transfer from the shallow movement across the plate, usually to the north-northwest or across Alaska, but ultimately terminating over in the East Pacific. So earthquakes in the West Pacific cause earthquakes in the East Pacific, and this is another forecasting principle. So when you see large activity in the West Pacific, you can expect large activity in the East Pacific within a matter of days' time or less, a few days' time. It's similar in size, and you'll see it spread out across the plate into the silent zones, where the silent zones tend to be the next spots to be hit. So you watch for your silent zones, and in the middles of the silent zones, or the fulcrum point of the silent zone, is the next spot to usually be hit. The magnitudes are determined by the nearby magnitudes. So, or if we see a large earthquake over here in the West Pacific, let's say a large 7 strikes over here, shallow, over in the Solomon Islands. We need to watch for a swarm of 6s or a single 7 to strike over here in the Southeast Pacific within a few days' time in South America right along the coast. Pressure transferring from the West Pacific to the East Pacific. Up in Japan, if you see large movement strike in Japan, Kuril Islands up in Alaska, we'll see large activity along the west coast of the United States. Forecasting principle. Have to take that into account every single time you do the forecast. The way you forecast, you look at the last 48 hours of activity. And I found that 48 hours is the best way to look. If you look a little bit longer than 48, it starts giving you older earthquakes that have already played out their pressure. The pressure's already transferred. So look at 48, it's going to show you the most current. It's going to show you where your swarms are, and it's going to show you where your silent zones are. Your silent zones are the next spots to get hit. And the magnitudes that strike the silent zones are determined by the nearby movement on either side, and you have to combine the totals. Not an average, you actually have to combine the totals. So you say, okay, well there's a 5.0 here at a shallow level, another 5 here, a 4.7 there. Then we have a silent zone, and then we have another series of 5.8, 4.6. Well, if you add that all together, that's going to take you up into the 6.0 range. It takes 10 5s to equal 1 6. Okay? And we go up 2 magnitudes, it's going to take 100 4s to equal 1 6. Does that make sense? So, if you start adding these together, it's going to take us up 1 notch beyond the 5.8 to the west. Right into that low 6 range. Right? So, 5.8 plus a 5 and some 4s goes up into the 6 range in the middle of the silent zone. And it most likely will strike right in the middle of the fulcrum point. Okay, so there we got that silent zone there. That's just an example of what to watch for. You guys can compare. All right, go ahead and watch over the next couple days. Also, we have a deep earthquake here. Several deep earthquakes, but over the last 24 hours, one deep earthquake, 4.3. Watch for a shallow 5.3 to 6.3 off this deep 4. Forecasting earthquakes, knowing where a shallow, large earthquake is going to strike. And finally, up in Japan, we are watching in Tokyo based upon our deep 7.7 and our swarm areas, and this being the silent zone. Middle of the silent zone between the spot that moved at the 5.2 and the spot that moved all the way over here in Alaska at the Aleutian Island chains. We're right down in the middle. This takes us back down into central Japan, where they issued a false 9.1 earthquake alert based upon a lightning strike at a seismograph. I don't know about that, guys. Something's up with that. So I hope this whole thing is a little bit self-explanatory. When we see the movement strike, we see it strike, and it's so basic that we're talking about basic physics. There's no special physics involved with this. And I think once people can get their heads around that, and that the professionals were wrong in what they said about earthquakes not being able to be forecast, that they just need to correct themselves. Say they were wrong. They didn't know. That's okay. People are wrong in science all the time. I proved my case at this point, and now it's just a matter of writing the book to immortalize it forever. And nobody can take it except for me, because even if they try to steal it right now, we have years of documentation where I've been smeared by the biggest professionals in the industry over this very topic. I want to thank everybody who's been in here, who's been part of getting this out to the world over the last 5 years, 6 years. You know, this December will be year 7, start of year 7 for me online here. So it's been a long process. I basically have a graduate degree in online. All right. It's just been a wild adventure of discovery and trying to prove my case to people. And at this point, the case is proved. So we're watching these areas. I'll have a forecast out by tomorrow that'll cover the next 7 days. You guys can feel proud to share that. Know that we're watching the areas and that they're being hit as expected. Okay? How many people are in here right now? Oh, wow. Hey, all right. Looks like 419 people in here. That's really cool to see. If you're not already subscribed, please subscribe. I have to ask because that's how I grow. We just passed 150,000 this week. So 6 days ago, I hit 150,000, and now here we are at 151.90. So I've gone up 1,090 subscribers this week. And I can only grow by you guys. Mainstream media is not going to touch this unless they're forced to, because they all denied that earthquakes could be forecast. So now when somebody comes along and does it, makes them all look foolish and they want to try and hide. Well, don't let them hide. Look, I mean, the bigger things have been discovered before. I'm not trying to ask for a Nobel Prize, although that would be nice. But, it doesn't matter really. I mean, if I get a reward for it or even acknowledged for it, I want people to understand how to forecast an earthquake so you can start watching yourself. Now you know what to watch for. You start seeing the dormant volcanoes get hit with larger earthquakes. Let's say a bunch of 4s, and this has happened before. Let's say a bunch of 4s start striking up and down the interior of the West Coast, over at the California border. Bunch of 4s, like 3 or 4 of them, striking at different volcanoes. And mainstream media totally doesn't report them to you, right? USGS might have them on their map, but no exclamation mark next to it, nothing. And then those 4s are immediately followed by a mid-5 off the coast a day later. Well, that's a warning sign. Your 4s are letting you know there's something larger coming and pushing all that to begin with. So when a larger earthquake's going to come, you'll have the same kind of warning signs. Like a pressure release valve, you will see these spots start to pop before the big one hits. And that's awesome news for everybody on the West Coast. You should, I don't know why people aren't more excited about what I'm telling you right now, because it means that you can lose the fear of the big West Coast earthquake, because we're going to have a couple days notice. We'll have at least 1 day's notice, certainly 1 day, more like 2 to 3. And if if I can really get this refined down, open up a laboratory and start doing the appropriate studies, get the appropriate financing to do this real, that we could get up to a good 5 to 7 days where we know for certain something's coming. All right? And we can really forecast the magnitudes very accurately at this point, down within a few points, and we can get the locations down to a few hundred miles, just doing it on my own. One-man operation can get it down to a few hundred miles and get it down to a few points in the magnitude on most of the large earthquakes that are striking in the world, and on the West Coast, even moderate earthquakes, 3 to 4s. And I'm not patting myself on the back. I just got to tell you guys, scientifically speaking, I don't see how you can ignore it. So if you're listening, you're a skeptic or you're a denier or you're a professional, just doesn't want to believe, I'm sorry, I'm confronting your beliefs. But, this is science. I don't really care what you believe. I'm here to tell you that we're doing it. You can go ahead and observe it for yourself and repeat the process yourself. You've been given the information as of tonight, yet once again, and it's all going in my book just to document it that I came up with the ideas to begin with. What you guys do with it after that is up to you. But don't try and take it as your own, because I'll come get you. I'll come get you. All right, so much love, everybody. That's a joke, by the way. Much love, everybody. I really appreciate all your support. And if you could, share my live stream with your friends, family, loved one, coworkers. Tell them that we're watching earthquakes 24 hours a day here. And even when I'm not here, we've got a grip of people that are in here that are interested